Where is the traffic jam in your body? The where's the choke point? Where's the most important place in your body that causes unknown complications? There's one place. Okay, I see that. There's one place in the body that I want us to really focus on. So, how often do you hear someone that has blood sugar problems, blood pressure problems, and kidney problems all together? How often do you hear? I used to marvel at that. It's like, aren't they all different things? But they're all related because of the great body traffic jam. So that's what we're going to talk about today. Webinar 68. I can't believe it. We're halfway through May, and I'm just so thankful to see you all here. And we met Ernie, the erythrocyte, last time, and he doesn't have on his super cape today. He has on his traffic cop vest today because he knows that this traffic jam is important, where sugar, pressure, and kidneys collide. So, what if they're not three separate problems? What if they're all related? And that's what I would like to share with you today, that they absolutely are. So blood sugar is the fuel for your cells, and so that's the fuel traffic. Blood pressure propels the traffic. And your kidneys, well, they're where everything happens, and they are the cleanup and the filtration crew. And the pileup happens when all three collide. There aren't three unrelated headlines. They are one connected story. So we're going to discover today 3 secrets, and I have a bonus secret. You know I love bonuses. Do you love bonuses? Okay, so secret number 1, the kidney filter runs under high pressure on purpose. You ever have people, well, I have people come to me a lot and say, do I have a temperature? You think I have a temperature? I'm like, of course you do. Everybody has a temperature, even if they're room temperature. You have a temperature. But I know they're asking, do you have a fever? And I give a trick question sometimes. Is inflammation good or bad? And the answer is it depends, because your body uses inflammation to heal. So, when is inflammation good and when is it bad? That's a whole nother talk. But high blood pressure is your blood pressure. Do you have a blood pressure? Right. Everybody has a blood pressure. It is your blood pressure a Goldilocks number? And that's what we're talking about too. When it's too high, that's a problem. When it's too low, that's another problem. We want to keep it just right. So you need a certain amount of pressure for your kidneys to function properly. But high blood pressure adds more pressure on top of the normal high pressure that is there in the glomerulus. And then number 3, high blood sugar can also damage not only the traffic, the red blood cells, but it also damages the passageways, the roads, the blood, the capillary linings. And the bonus secret is there's something that we can do. We can help to nourish and support our glomeruli. So all of our capillaries really, but we're focusing on a special kind of capillary today. And I've used that word twice already, but I'm going to explain it. But before I do, I'll explain myself. So hi, I'm DrLisa Singletary, MD, MPH, CWHC. I'm also known as the 100-pound weight loss specialist. And through my 5 M's of total transformation, I empower you on your health journey to optimal wellness. And these are some pictures from my health journey. I'm still on the journey today, but I saw a video of myself from early 2015, and I did not recognize myself. So I'm so happy that I've had some success on the journey, and that is how I developed the 5 M's. And this is my 6th M, which is miracle, because I needed a miracle in my health journey. But we don't talk about miracles in health and wellness. This is really my reminder to give a disclaimer. And ChatGPT was very nice and made me a disclaimer slide. So this is educational, maybe a little entertaining, I hope, not personal medical advice. This is not a second opinion. This is not something your insurance is not going to pay for me, right? So what I want to do is give you my knowledge and help you to ask better questions and have better conversations about your health so that you can work with your healthcare team. So I have 3 articles today. The first article is just a basic article. Basic. It's a fascinating article. But what are your kidneys? And we're going to start there with the structure and function of your kidneys. Just an overview. So this shows where your kidneys are in your body. They're in your back, basically, just below, like they peak below your rib cage. So they're not protected completely by your ribs, which is why boxers know that kidney punches are illegal, because they know how much damage can be done to that organ and then how important that organ is. Now, you don't have to know all of the parts of this thing, but what I want you to see is that there is an outer area, and you could think of it as the coating. Actually, the word is called the renal cortex, and the word cortex means bark. So if you think of the tree has bark on the outside, but then it has a lot of stuff on the inside. So the cortex is this outer bark area. And you can almost see some little teeny white lines going all the way through the cortex. We're going to focus in on those lines because they are a huge part of the story. In fact, there are millions of them in your kidneys. And they are, like I said, I'm going to show you exactly what they are. So that's the outer part of the kidneys. Now the inner part, we see these, you call them pyramids, and you see them all through here. Again, the pyramids are all tubes too, but they are different type of tubes. And then you see wrapped around all of the tubes are your blood vessels. And what happens in the kidneys is red blood goes in. So the red blood is oxygenated and it's full of nutrients and goes to all the parts of the kidneys, and then deoxygenated blood comes out. But the other thing that comes out is urine. So how does blood go in, but blood and urine come out? That's the whole story of today. So this is a model. I have other I couldn't find a picture that was really defined, but you'll get the point. So on this kidney on the left, we see the outer cortex, right? The bark, and then the inner medulla, which is where the pyramids are. And You can see all these lines in the cortex. Like I said, there are millions of them. So we're going to take one pyramid and blow it up. And that's what this is. So this lighter area is the cortex, the bark, the outer area. And this inner area, or this triangle area, is a pyramid. And we see in the cortex, why is it so light? Well, it's got all these little ball structures. And those little balls are the stars of the show. And so we're going to take a look at the balls. And the little balls are called renal corpuscles, and inside the balls are called glomeruli. I'm going to break it all down. So this is a corpuscle that's got the glomerulus inside. Now, the glomerulus is a special type of capillary. They are the smallest, most delicate blood vessels in the body. And these capillaries are where everything happens in the circulatory system. Everything else, just getting from the heart to the lungs and to the tissues and that's just plumbing. But the action happens at the capillary. And so this is a normal capillary. This is a normal glomerular capillary, but this is a specialized capillary. And I want you to see the difference. So in normal capillaries, and this is what we're taught in school, there's an arterial side and there's a venous side. And in the middle, in the capillary bed, that's where the oxygen exchange happens. That's where nutrient exchange happens. But here's the thing. One side is arterial, one side is red, the other side is blue. Right? Can you see that? On this capillary, so again, a normal capillary, one side is red. Then once the oxygen is deposited and nutrients from the blood, the other side is blue. Now, your blood's not really blue, right? But it's how we depict it to show that the oxygen has been diminished. It's not all gone, which is amazing. But in the glomerular capillary, both sides are red. There's no blue here, right? And why is that important? That's important because of pressure. The other thing that's important is in the normal capillaries, we see the cells, but in the glomerular capillaries, there are holes or pores in the lining of the capillary, which is amazing. But that's why filtration happens, right? When you want to filter something, you've got to have a way for the liquid to get through, but to keep the red cells inside, to keep all the big particles inside. And that's the function of those little pores. So another picture, we've got the outer core, the outer rim, the pyramids, and then in the outer rim are millions of these glomeruli. And then when you blow it up, you see cells come in, the blood comes in, and this is the key. The blood, this area is under pressure. Why? Because the road going in is larger, but the road going out is smaller. So it's like when you put your thumb over a hose and that builds pressure inside the hose, and that causes pressure in this area, and that pressure forces liquid out of the blood and into this glomerular space. And this liquid, which is called a filtrate, is going to become urine. But what stays inside is all the blood cells, the proteins, all the particles that help to make up the blood. Now, what can happen when things go wrong? So here's another article for you, and just scan the QR code. And we're going to talk about some things. Can you believe it? About 37 million American adults have kidney disease. And I think that number is good. This is an old number. That number has gone up. But how many of those, a huge percentage of those, have high blood pressure and diabetes? So what are the secrets? Secret number one, there are, like we just saw, two types of capillaries in the kidneys. The high pressure there drives filtration, but the regular capillary, I say regular, they're normal, they're regular, but the capillaries that are all over your body, the ones that go from a red side to the blue side, they work at a very low pressure, 10 to 15 millimeters of mercury. And that's good because since it's so low, everything can be absorbed from the bloodstream into the body. Now, when we see these numbers, millimeters of mercury, well, what is normal pressure? You already know the number, right? 120/80. So the blood pressure when your heart pumps is 120. That's a lot of force, but it's got to get the blood circulating all over your body, so it needs that pressure. Once it gets to the capillaries in your kidneys, there's still a lot of pressure, 45 to 60 millimeters of mercury. And that pressure is perfect for filtration. But then, what happens when your blood pressure gets higher? No bueno. Okay, I'm gonna get this. All right. So again, we need the pressure so that this works, so the filtration happens, but we don't want it to get higher. We saw the picture of the two arterioles. Both sides of the glomerular capillaries are red. There's the afferent, which means incoming arteriole, and then there's the efferent, which means the exiting arteriole. And the exit ramp is narrower than the entry ramp, and that maintains pressure inside that capillary tuft. So it's not just a little side street. It's a high pressure toll plaza built for filtration. But what happens when your pressure goes up? Then you're putting pressure on top of pressure. It's already a high pressure situation. So when your blood pressure is elevated, then you're adding stress to the capillaries. And that lining of those capillary, the lining of the capillary vessels is only one cell thick. So one little cell can get damaged and start a cascade of problems. So we want to keep our blood pressure in check. Even a little bit of elevation in our blood pressure causes a big shift in what happens in our glomerular capillaries. We got to protect. We got to protect those capillaries. So when you put high pressure, you're stressing those smallest passages. Secret number 3. All right. So secret number 1 is there is a normal amount of pressure. We need the pressure for it to work. But secret number 2, we don't want the pressure elevated because that sets up a situation for damage. Secret number 3. Now, what happens when sugar gets into the picture? Your red blood cells have to be flexible. Why? Well, a red blood cell is the average red blood cell is about 8 microns wide. Now that's a very, 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 very small width. And who knows, mentally how big a micron is. Very few people can even imagine the micron, but let's focus on the number 8. So the red blood cell is 8 microns wide. The smallest capillaries are about 4 microns wide. So a red blood cell has to be able to fold and be flexible and maneuver to get through those narrow, narrow passageways. In a healthy red blood cell, it's soft, it's spongy, it's flexible, it's pliable, and it can squeeze right through the smallest capillaries. But in a high sugar environment, the sugar attaches to the red blood cells, and it causes them to be stiff, and also it causes them to be jagged on their edge, on their surface. So these stiff, jagged red blood cells are trying to fit through these narrow capillaries. It's harder for them to get through, and it can damage the capillaries as it goes through, just from having those jagged sugar crystals on the red blood cell. So you add the red blood cells being jagged plus pressure, because your heart has to beat more and force those red blood cells through the capillaries. And again, no bueno. So high sugar can damage the road, which is the capillary linings. Glycation, we've had this word before, it affects the cells, not only the lining of the red blood cell, or the surface of the red blood cells, but the sugar gets inside the red blood cells. And you can see here, right, we've got normal red blood cells on the left, which is under a normal sugar situation. But if the sugar is high over here on the right, the red blood cells are going to be swollen. They're going to have jagged edges, and when they're forced under pressure through these little capillaries, there's going to be damage. So the traffic is part of the problem. These less flexible red blood cells make a tougher trip through the delicate capillaries, and it causes damage. So it's a triple threat, right? The high filtration pressure, the added strain from excess red blood pressure, and then less flexible glycated red blood cells in the traffic. The endothelium, the lining of the glomerulus, is under siege. So imagine the damage. There's too much pressure inside the capillaries. They can burst, right? There's not enough fluid in circulation. Most of us are walking around like potato chips, dehydrated. A little bit, but still. If you don't have enough fluid in circulation, then you can have like mini clogs just because there's not enough fluid for the blood cells to flow through properly. Capillaries are blocked, partially or completely. Big problem. We've got to have flow, right? Everything has to flow in our bodies. What happens if your air doesn't flow? What happens if your bowels don't flow? If your urine doesn't flow? If your blood doesn't flow? Problem. So when something gets blocked, we're looking for trouble. We don't have to look for trouble. We already have trouble. What if the red blood cells have these sugar trees on their surface. They're not going to be able to get through. What if the sugar gets inside the red blood cells and increases the glycosylated hemoglobin, the HbA1c? What if the red blood cells, because of the proteins and the sugars, get sticky and they form these, they call these rouleau formations where they stack up. Now, this is, there are ways that this stacking, just the structure of the stacking, is beneficial just because it puts them in order for them to slide through the capillary. But they're supposed to be individual, not stuck together. So this is good for when you're trying to. Maybe I know I'm dating myself now. One of my jobs as a little girl was when we collected money from church, was to get the pennies and put the pennies and the nickels and the dimes into sleeves to put them in, to take them to the bank. And I used to do this in my hand with the pennies because they could slide in, like a big stack at a time could slide in. But the pennies were all individual. So even though they were sliding in formation, they weren't stuck together. These rouleau formations get stuck together. Okay. So the medical solution: expensive medications, injections, dialysis. But what if we could help the capillaries out somehow? What if we could support them? How? What if we could help to decrease the inflammation? We could decrease the pressure. We could decrease this sugar damage. We could decrease oxidative stress. What if we could increase the flow and decrease the stickiness of the red blood cells? So here's the bonus secret. Nutritionally, we can help support the flow. We can feed the flow. So that helps nutrition, I'll just read it. Nutrition supports for capillaries, blood flow signaling, and red blood cell flexibility. Now, you might have heard of nitric oxide. That helps to dilate the blood vessels. And we're going to talk about how to support the road. That's the lining. To support the traffic, those are the cells, the red blood cells. And to support the flow, which is how much fluid is in the system. So I found this article, and a lot of big words here. Glycosaminoglycans and fucoidan have a protective effect on experimental glomerulonephritis. What does this really mean? Glycosaminoglycans come from medicinal mushrooms. So mushrooms and seaweed help to protect the kidneys, specifically the glomerular, where the traffic jam happens. So I just love this, having this specific article focused on the glomerular. So what can we learn for our bonus secrets? Open the lanes. Nitrate-rich foods help the body make nitric oxide, and that helps to dilate the capillaries. Protect the surface. Antioxidants help to decrease oxidative stress and allow the repair crews to repair the lining of the capillaries. Keep the traffic supple. So we want the actual membranes of the red blood cells to be flexible and supple and sugar-free. And we want to guard the lining. So fucoidan, more and more research about fucoidan helping the lining of the endothelium, or the lining of the blood vessels. So Where does this all fit in our 5 steps to nutritional completeness? Step number 1, avoid the bad foods. Step number 2, we must have the 90 essential nutrients as a foundation. Step number 3, antioxidants and adaptogens, anti-inflammatories. Now we're helping to protect and we're helping to uh, allow the body to repair the damaged capillary linings. Step 4, your digestion. Again, you have to have flow, you have to have a healthy microbiome and a healthy gut lining in order to absorb all the nutrients. Step number 5, I love it, Wellness Wonderland, all of the targeted strategies. So blood sugar support, kidney and liver support, joint support, brain support. All of these different things are in Wellness Wonderland, but they all have to be on the foundation of avoiding the bad foods, 90 essential nutrients, and giving the bodies that antioxidant boost and having a healthy gut. What are the 90 essential nutrients? 60 minerals, 16 vitamins, 12 essential amino acids, and 2 to 3 essential fatty acids. And the word essential means your body needs them and your body can't make them, so you have to supplement. So what we discovered today, 3 secrets plus a bonus. Number 1, the kidney on purpose has a high pressure filtration system. But when you add high blood pressure on top of the normal high pressure environment of the glomeruli, that's a setup for damage. And then you put high blood sugar on top of that, then it's no wonder that the 3 go together. And we don't want that to happen. But this phrase stuck with me when I was in medical school, that diabetes is a microvascular disease. And it's because of just what we've been talking about today, the sugar attaching itself to the red blood cells, and they are scraping the inner lining of your blood vessels as they're forced through the capillaries. But what is our bonus secret? We can support our capillaries with nutrition. So I made this little summary, and this is going to be a gift for you, but I made it in a lighter background, so it's more printer friendly. But this is a summary of all the things we've talked about today. And if you scan this QR code, you can get it. It'll download right to your phone or your computer, and you can review this information. You can share it with your family and friends. But more and more reasons we have to avoid the bad foods and, nourish, hydrate, and detox properly. Your next step, there's a brand new community. It's called the Elevate Your Health Community. And you get free health education in there. There's an ebook. There's a free health course. And the community is very supportive. And it's chock full of certified holistic health coaches. And if you want to just learn more about the way to nourish and support your body, I welcome you to scan the QR code and join the community now. Now, some of you are on the replay today. I want to welcome you back to a live, and thank you for those you are here live. Our live webinars are Saturdays at 11 a.m. Eastern. Scan the QR code. Registration is open. And tonight, for everyone that's here particularly, we're going to be putting this replay up on YouTube. And I will be in the comments, in the chat, in the live chat for the premiere, which will be at 9 p.m. Eastern. Of course, after that, it's going to be available all the time. But I want to welcome you to join us tonight if you got any questions in between. And also make sure and look in the YouTube description because I put the links in there for all of the goodies that I make for you. All right, so we're shedding light on the secrets, and that is webinar 68 in the can. The red Corvette's getting ready to ride, and I love you all. Those of you who are here live, stick around. We're going to have a little chat. But those of you on the replay, thank you. I love you, everyone. Mwah.